In the previous video, we got our advanced driveline axles in, we got them under the Jeep, and then we've been hopping around with projects all over the place. But it is a nice cool day in the shop, and we're gonna take a look at the steering setup on this advanced driveline Super Kingpin. We do get reed C's and reed knuckles, and this is a fantastic steering setup. So first, we'll take a look at the knuckle. Our tie rod, if we mounted it on top, which these are designed for, they're actually beveled in, that would put us right in the middle of the tube for our tie rod, which is fairly decent high. And then over here on our drag link, we get a nice machined high steer arm. So this is a 6-stud high steer arm, which is right off the bat pretty beefy. We got ARP studs and this 1-inch thick, it's actually solid steel. It's machined with, I think, a 10-degree angle for our steering. That way our joints aren't bottomed out. But this is a fantastic arm. It has the setup spaced appropriately for a JK, that's your Ackerman angle. And for the most part, this is a super, super strong setup. But since we are racing and building this thing to really handle anything out there, King of the Hammers, we are going to do an upgrade for our already upgraded piece. So this is from Ballistic Fabrication. It's a double shear high steer arm designed for this reed knuckle. So what we have here is a double shear bracket and a, once again, solid steel high steer arm, but we actually have the knuckle tie rod mount incorporated into this. So there's a few things going on here. First, we get a double shear heim joint pocket right here, which is going to hold that joint a little better. I'm not sure if we can use that yet because that's gonna actually stack our heim joint on top of this, and we'd have to, look out for frame clearance, but we're not there yet. We can either mount it in a high steer setup or go down below in the single shear, which isn't ideal, but if we have to run it, we have to run it. The biggest thing I'm looking for in this kit is the tie-in bracket right here. So I highly doubt that we would shear all 6 of these studs off the arm, but you never know. Just for a little bit of extra strength, we're now gonna tie this upper arm into the knuckle down here, which should strengthen this unit up a little bit and just prevent any kind of shearing from happening whatsoever. What we're gonna do is change out this high steer arm with this one and see how it looks in the end. Now we are battling a lot of red Loctite on these guys, so we're gonna heat them up, blast those off, and this centerpiece here, this is actually how you set your kingpins, kind of the preload, how hard it is to turn the knuckle and rotate it. Went ahead and backed that off. We're gonna loosen that up before we pop these off, and let's get this arm out of there. I realized that it would have been a lot easier to drill this hole out before we installed this, but hey, oh well, we'll drill it out from the bottom. But it's time to actually set our kingpin drag. So what we're gonna do, I actually have to wait to set it like officially tomorrow. Got to get a little fish scale or something that you can measure drag with. But we're gonna go ahead and just kind of bottom this top pin out, and that's what pushes on the kingpin. And all it is kind of sets it up on how tight the kingpins are, but how tight it is to turn the wheel. So once I'm getting a little bit of resistance right there, we're gonna move it back and forth. So that's way too loose. We're looking from like 15 to 20 pounds of pull. So we are all finished up with our double shear high steering arm. It's time to move on to the rear axle with a few more upgrades. Now the rear axle is just as beefy as the front. 14-bolt center section, 4-inch axle tubes, and the tubes are welded to the diff, both sides, front and rear as well. So the issue isn't that we're gonna bend the rear axle. That's not why we're trussing it. It's more so of where we are placing our suspension link tabs. So we are running a triangulated 4-link rear, which means our upper links are gonna be running on a truss on top of the axle. This puts a lot of load on this truss right here. Now, luckily Barnes makes some incredibly strong trusses, and just to go one step further, we're beefing it up even more with a 14-bolt pinion guard incorporated with a truss bridge. So what all this is going to do, we'll go ahead and step back a little bit. This is the Barnes 4-wheel drive Pro Series 14-bolt truss, which is like a low profile mini truss for the 14-bolt. Now, since we are running 4-inch axle tubes, this is not designed with 4-inch axle tubes in mind. Mike and I had to open this up, shave all this down to make sure we got a nice fitment on the 14-bolt. I also went ahead and painted the inside with Steel It. That way, once we make all these welds, we don't have to try to reach up underneath and paint it. And to finish it off with a nice clean look, went ahead and drilled a hole for our vent tube on the axle and put a repair weld washer from Barnes in there and welded it on the inside. So I think that gives it a pretty clean look. We have to tack all this up. Now, what does this do? This incorporates a pinion guard into a truss bridge. So we're gonna tie in the back of our truss into the housing via the pinion guard. So this is designed to fit around their tall standard truss. So Mike and I had to cut this down, lower it to match this. Now on the rear here, as you can tell, I went ahead and painted the center section of the diff. Used the Ace Hardware satin black. This stuff just works really, really good. So the pinion angle is set. Used a laser from the pinion nut up to the output of the transfer case. Now we can weld the truss on nice and centered. Man, that is a lot of talking. Let's go ahead and get this all put together on the Jeep and get this tacked up. We have this little piece of metal here that slots in through here, and that's the piece that we are going to weld and attach to our truss. So I went ahead and welded the entire truss on. It's really important, you know, to tack each corner, start in one section, do a little bit of weld, flip it over, do the other one, let it cool. What we really want to avoid is prematurely bending or warping the housing from welding all the heat and distorting it. You know, with 4-inch axle tubes, there's probably no way we were gonna bend them, but make sure you take it nice and slow. So that is all done. We are welded around the side, and now it's time to come over here to the bridge plate. So this plate is adjustable, there's slots in there. We wanna go ahead and loosen them, bring it all the way up against the truss, and then I tightened them down. So now we can weld this plate right here, and it is structurally together as one solid unit. If we ever need to remove our pinion guard, all we do is undo these 3 bolts right there, undo the 6 pinion nuts, and it slides right back out. So it's a really cool setup, and I think this is going to be a fantastic 14-bolt rear axle. So last night, finished up welding the truss. It is all done. So the truss and the pinion bridge tie-in is complete. And Mike and I have been extremely busy this morning because it is time to start working on the suspension links. And there's quite a bit that we need to dive into on exactly how we're figuring out how to set up our suspension. So like I mentioned, it's going to be a 4-linked rear triangulated upper. We'll start off by taking a look at some of the brackets we're using. On the frame side, we have our 3-bolt 4-link tab. So we have 3 adjustability spots. Over here on the axle side, we have the Barnes 4-wheel drive axle brackets, but we had to open them up to 4-inch diameter. Everything that's on the axle has to get opened up to 4 inches opposed to the standard 3 or 3.5-inch contour. So as you can tell, we open that up. These sit nice and flush. These are their offset brackets, 20-degree angle to point it in for the triangulation. Over here on the frame side for the uppers, we used the C-channel builder's plate and actually chopped off one leg, and here we have their 4-link bracket. So how this sets up over on the frame is we have the C-channel builder's bracket, and we have one side already welded up just to show you guys what it looks like. So the good thing about these channel brackets is it strengthens the spot on the frame wherever we're welding these brackets to, and really distributes the load a lot better than just welding this bracket on these spots on the frame. Real quick rundown on 4-link building. On the rear, you want to have your uppers and lowers pretty much the same length. On the rear, we don't have any caster to worry about, so we want our pinion angle to point directly at the T-case. And if our links are the exact same during droop and up travel, that pinion angle is gonna stay relative to that point right there. Now on the front or on the rear, if we made the upper shorter, it's actually gonna swing and our pinion angle isn't gonna follow, it's almost going to stay level. On the front, that helps with caster, but in the rear, we are only worried about pinion angle. So we're gonna come over here and open up our 4-link calculator. I'll put a link to this in the video description. It's an Excel file, pretty easy to use. It looks very complicated, but once you get into it, it's pretty simple. We're gonna start over here on the left with the vehicle specifications. Plug in our wheelbase. We're gonna be sitting right around 108, 109, maybe 110. I just put in a lower one to start off with. Tire diameter, 37. The rolling radius, that really doesn't matter as much, but that's kind of how flat the tire is on the bottom, how much is actually touching the ground. Vehicle center of gravity height, we take that measurement from the upper bell housing bolt down to the ground. That's an approximate vehicle center of gravity. How much it's gonna weigh, we have no idea yet, so we just plugged a estimate in there. My mouse keeps freezing. All right, front unsprung mass, it's gonna be the axle, same as the rear, just threw in some numbers. And then we move over here to our link numbers, and this is where we actually start taking measurements. So here you can tell we have a little picture from the side and a picture from the top. So you can tell right off the bat if your numbers you're plugging in throw it way off. Blue is gonna be the upper, red is going to be the lower. So we'll start on the lower links. We knew that the height from the ground on the lower links was going to be on our Clayton cross member. So that was an easy measurement to take. From the ground up to where those Clayton 3-link mounts are gonna mount is 20 inches. On the axle end, with our flush mount brackets, we mocked those up and that gave us 18. So that's, you can see it right here. It's flush mount on the axle and goes up a little bit over here on the frame end. Then on the axle side, we have this Y measurement, which is how spread apart they are from the center line of the axle. So we measured ours from the center line of the axle over to the mount, and that's 23 inches. We're gonna do that on both sides. Over here is forward from the rear axle center line. So we find the center of the axle and how forward off the axle our bolt hole for our joint's gonna be, which is 4 inches in our case. Now moving over here to the frame end, we have forward of the rear axle center line. So that's gonna be our Clayton cross member, how far those bolts are from the rear axle. And then over here, the Y-axis is how spread apart they are from center line on the frame to our Clayton cross member. So we plugged all those in. Then we move up to our upper links, same thing. Height from the ground, our upper links on the frame is 25.5. And on the axle end on top of the truss is 27.5. These are the distances between the two, and the frame end, how long that link is. So once we have all those in there, I know there was a lot of talking, we can come over here and see what number our anti-squat is. So in our case, our static anti-squat for this setup is 64%. Now 100% means when you give it gas, the back end just stays level. If we're above 100, the back end's gonna wanna rise under gas. If we're under 100, that's 64, the back end's actually going to dip down. Now, what number you're shooting for in anti-squat is, it's gonna depend on your setup and what you plan on doing with it. But generally, right around 100 is perfectly fine, and a little bit under is perfect for rock crawling, right around 80, 90%. But as soon as we start going faster, doing more desert racing stuff, we wanna get a lot lower, anywhere in that 50 to 60%. So with our setup, this is how everything's looking. We can check our travel, and we are going to go 5 inches up travel. And we can see our little picture there just popped up. Our anti-squat goes to 43. At 7 inches of up travel, it goes to 34. We can go down travel. Let's do -10. At 10 inches of down travel, our anti-squat is only at 102. So when we're fully flexed out and we get some traction, it's not gonna wanna start hopping. I am happy with this. Now, another thing we do wanna look at is check out our roll axis is at -3 degrees understeer and -2.76 degrees, which is not bad either. With the barn's upper link mounts, we have those 3 holes. That's gonna put us at 24.5. as an option, which bumps it up to 77% anti-squat. We were just at 25, and our next hole is 26.5, which lowers it down to 52. So right in the middle at 25.5 gives us adjustability for our anti-squat to both go up and go down. I know that was a lot of talking, but that is how you use the 4-link calculator, and it's one of those things you're gonna have to go back and forth, check all your measurements. And if you're not happy with the numbers, there are a little bit of there's a few things you can do to move the brackets around. For example, if we wanted to get this any lower to change our anti-squat numbers, we would have flipped the plate upside down and mount this on the bottom of the frame, but I wanted to shy up towards the high side of adjustability. So that is a basic rundown. With all of that being said, it's time to grab these link brackets, take the measurements, double check them, and then weld them into the frame. So the driver's side lower control arm mount is done. We're working on the passenger. So we've already measured out equal length from the center of the tube over here to where we're gonna mount it. What we're gonna go ahead and do, throw a bolt in there. That way we can line up our line on the axle tube with the heim joint to make sure it's centered. Now on the other one, we have our height from the ground up to the bolt. We're gonna mimic that exact same height and then tack weld it in. And we should be able to put an angle finder on the bottom of each, and it should be the same degree of tilt. But for the most part, we're keeping them fairly flush while still giving us enough separation between the lower and the upper, and everything's happy in the link calculator. Right there. 74.5, 74.3. So within a 0.2 degree of one another. With adjustable links, I think we'll call that good. Now that we have the rear finished up, it's time to move on to the front. Luckily, the front is a lot easier since there's only one upper link. Our lower links are once again going to our Clayton cross member over there. So all we have to do is figure out the axle side lower control arm bracket placement. But up here for the upper 3-link, once again, we used the Barnes 4-wheel drive, just their universal 4-link bracket. Same ones that we used back here, we placed up here. Now, we did have to notch it out a little bit. We took some away and kind of braced it up in here just because on the rear, we were able to butt it up directly on the cross member, but up here we had our out-of-hand fab brackets. So we kind of had to contour it to the contour of that brace right there. So we knocked that out, got that tacked in place. It's nice and high up on the frame. Once again, with 3 different bolt holes to adjust our anti-squat, but in the front, we're actually looking at anti-dive. So we have adjustability on this side, and over on our axle side, we have the Barnes 4-wheel drive 3-link axle side bracket, and this also has 3 holes for adjustability too. Things we're looking for up on the front, very similar to anti-squat, but in the front, it's actually anti-dive. So with our planned setup, we're right around 83%. So when you hit the brakes, the front will compress slightly, but a lot of that can be tuned out with shocks. What we don't want to do is hit the brakes and have the front end rise, which would be over 100% anti-squat or anti-dive. So that is a lot of talking. Let's get these burnt in, and then same thing for our lowers, which we have over here, already opened up to 4-inch on the tube. These are their offset brackets, and we have drilled the holes out to 5/8. So let's get the front all set up. Now for the lowers, we're gonna do the exact same thing that we did on the rear. We're gonna set it nice and level, get our angle finder, and make sure both sides match. But what we're dealing with on the front is a few things. So here we have our dual shock brackets, which we'll talk about in a little bit, but we have to make sure that our link has enough clearance for that shock bracket. So we might, in the end, kind of rotate this bracket a little more down this way. We're not sure yet. That's going to be once we're actually, flexing it out with the coilover and bypass. But as long as we clear that right there and have a little bit of room for adjustability, we should be good to weld our lower links. Now, typically you want to keep your lower links out as far as possible, but I don't want to run into any issues with that in the future. So right around here, we're going to measure this spot from the center line of the axle, and then do the same thing on the other side. Time to move on to the next project, which is mocking up our PSC big bore steering box. So this is already a humongous box. We're gonna try to move it forward about 6 or 7 inches. We're gonna have to brace the frame. That's gonna be for a future video. We actually have a guy coming out here to help us figure out how to do this. But in the meantime, we can go ahead and put on our new bumper from Out of Hand Fab. So what we need to do is remove this crossbar that goes between the frame. Since our steering box mounts inside, typically it'd be right here. We're moving it forward right to where this is gonna be. Now, before we chop that off, wanna have some kind of cross member up here on the front so the frame doesn't wanna bow in or bow out. So that's where our new bumper comes into play. So this is the Out of Hand Fab Hysteria bumper. It's a frame chop, and the nice thing about it is it does not have to be in a certain spot on the frame. We can adjust this all the way in, we can cut away a ton of frame, or we can leave it sticking out. So we're able to kind of put this bumper where we want. It's a good looking bumper. looks pretty well built, and it's gonna complement the rig pretty good. So we'll, you know, be able to tie in the structural roll cage up to the front bumper. There's a lot we're gonna be able to do with this bumper. It looks good, super high clearance, and we can really suck it up into the frame. So first things first, we've already done the frame chop on the frame with our last bumper. Went ahead and cleaned up the edges a little bit. We're just gonna slide this on, make this cut, and the bumper's gonna hold the frame together. More. So we started cutting and modifying this front corner of the body right here so we can fit our large steering box. You know, I say large, it's the PSC big bore box, so it is physically larger, but it's also stretched forward quite a bit. Now we're still waiting for the frame plates to come in until we can actually figure out where we're gonna put that. That should be any day now, but if we do move it any further, we're probably gonna have to cut out this entire corner here and rework that front structural piece of the fender. So that's going to be in the next video. That's probably about it for this one, guys. Like always, thanks for watching. Please give the video a thumbs up, subscribe to the channel, and in regards to the last giveaway or the last Jeep trivia question, still waiting on Vanique Hout family. It's the last chance to claim your $25 gift card. But that's it for this video, guys. I'll see you next week.